to introduce you because your CV and descriptions about your background are full of words I simply do not understand. So if you do not mind, I will ask with a question. What is space dosimetrics?
Space dosimetry is about the radiation protection in space, very easily.
Yes, I did not know anything about it, so I think that your presentation will be full of surprises.
Just to highlight, space dosimetry is one of the key problems we are facing in space for the humans. The humans cannot live in space, and cosmic radiation is so dangerous, and that was my original scientific discipline at the university. But now I am much more an aerospace engineer. I am working as an aerospace engineer and also working as a strategic advisor. I am working as a member of the European Space Agency Advisory Board. I am a member of the Moon Strategy Team, who is providing direct advices to the General Director of the ESA. I am also working as an advisor to our ministry, to the Ministry of Foreign Affairs and Trade, related to the space activities in Hungary. And thirdly, I am currently the program manager, so the strategic leader for the National Astronaut program.
So, Balázs, thank you very much for coming. We are very happy to have you here now.
Thank you very much.
The floor is yours.
Thank you very much. It's a pleasure to be here. And in the coming few minutes, or even more, I would like to give you an introduction into something very special. I think a National Astronaut program is still unique. And let me give to you a little bit background, because I think if you look around worldwide, we would see that the whole world is changing. We are moving into the new space age. And that looks like just words, nothing behind, but that's not true. Look around and you would see that from governmental space programs, we are moving into the commercial sector. The world is fully changing. Just look to one very interesting example, which is, I think, everyone is knowing well. This is the example of SpaceX. SpaceX can do something which 10 years ago was unbelievable to anyone. Just look what SpaceX reached as a commercial entity for now, and look around and you will find several commercial entities who are building its own space stations, building its own space vehicles, and starting to send humans into the space. In the next few decades, we will see a new area of space industry and space human flights. And that's what we realized on governmental level, because we realized that Hungary had long time ago its own astronaut program. Hungary was the 7th nation who sent a person into the space. And that was long time ago. All the background, all the capabilities was disappeared. And now we would like to re-establish everything. And in my presentation, I would like to show you some more details, some difficulties, how complex could be such a program. For the first view, it looks very easy, what we would like to reach, to have national astronauts, to send them into the space. Why so difficult? It's absolutely very difficult. It's still very difficult. Space is something which is not for human. We are living here. Our biology can live here. We cannot live in space. And it's not a nice thing, to be honest, to go into the ISS, to go into the space. It's a very difficult thing. And we need to prepare humans still a lot. And we need to convince the decision makers, all the people, why we pay a lot of money, why we invest into a program where we send people into the space. Why? Several times asking people, me and program managers like this, NASA, ESA, why we are doing this whole thing. And the reason, because look around and you will see that soon the humanity and the whole industry will be changing. Nowadays, if you look around, 10 or 15% of the whole industrial activity happening in space or related into the space. And if you look into the future, I would like to ask you what would happen within 10, 15 or 100 years from now, how it will change. And I certainly can be sure that almost 90% of the whole human industry in 100 years will be happening in the space. And that's the future of the humanity. And anyone who realizes this, anyone who starts to invest into it, will be in a much better situation soon than now. Just one very easy example. Everyone who has a cell phone has a very specific material in it called cobalt. It's required for its components. But cobalt is very difficult to find and mine within Earth. But why not to do it, mine it, and get cobalt on the moon, on asteroids, and bring back to the Earth? We can protect the environment here in Earth, and we can mine something somewhere else for much lower cost by robots. Why not to do it? And that's just one very easy example why we go into the space. So this program is a governmental program, and you see there are several logos, but the most important message that this program is founded by the Ministry of Foreign Affairs and Trade and subdelegated to one of the pioneering research institute called Center for Energy Research. I'm also working there. Center for Energy Research is dealing 50 years ago in Hungary with space research, which is in worldwide one of the longest history, I would say. So I have not much points to do to describe to you. First, I would like to give you just some insight what would be the strategy worldwide and where Hungary positioning itself. What is the human spaceflight strategy? If you look around, if you look to NASA, ESA, and if you look the commercial market and what Hungary would like to reach, then just the program overview. I think as you are mainly dealing with project management, I would like to focus a little bit on the project management principles of such a program. And then some highlight and achievements, what we achieved already, because we have already some achievements. You will see one of the biggest achievements that we are almost ready with the national astronaut selection, and within a month we will announce the Hungarian new national astronauts. So some scope and strategy. I think that's a very good graph to you to show what happened in the past, what is happening now, and what is coming in the future. As I mentioned, long time ago, 1980, there was the first Hungarian astronaut flight. It was the seventh nation, as I mentioned, Hungary, who reached that stage. But after that, until nowadays, almost nothing happened on the human space flight within Hungary. And now we would like to reinitiate, because if you look to that schedule, we can assess that ISS area is almost over. International Space Station is in orbit for a long time ago, and now it's reaching the end. By the end of this decade, there is no more ISS. ISS will be operated by commercial entities, but not by governmental entities. Why we use the ISS? Because we learned a lot. ISS was used to learn how to live in space, how to do things better, how we can change, how changing the biology, how changing material properties, how can we live long-term in space. One of the biggest questions, what is happening with human body or with any biological sample in space during a long-term space flight? Because if we would like to reach our end goal, to go to the Mars or to go even further, we need to know what is happening with us and how we can protect our astronauts. And the research basis for that was ISS. ISS program is now almost over. And what is coming is a new moon program. I think everyone heard the word Artemis program. Artemis program is funded by NASA. This is the humanity new moon program. And in the frame of the Artemis program, the humanity will go back to the moon. And it is much more than just go back to the moon. It is a pathway to go to the Mars. In the frame of this program, in an international collaboration, the Lunar Gateway is built up. Lunar Gateway is an ISS-like space station built in a moon orbit. But it's not a space station. It's a space vehicle. It's a station which will help us to go to the moon. So astronauts will fly from Earth to that station. Then they go to another vehicle and land to the moon. This is really a gateway to reach the moon's surface. But in the meantime, this is also a space vehicle. It can used as a spaceship traveling from moon orbit to Mars orbit. And it can demonstrate that in the near future, humanity will build up its Mars vehicle in moon orbit. One of the critical things how we can reach Mars and farther destinations with a low energy consumption, because we need a lot of fuel. And one of the easiest way, orbit in the moon. Go bring there all the fuel you need. Then start to orbit more and more elliptic, and then you have a point in the orbit which is almost very close to the Mars. And at that point you need a very little fuel to go to the Mars. And that will be then a precursor mission in orbiting Moon to prepare ourselves how to live in Mars. And it's still just an example. Moon is an easy place. Moon is one of the easiest places to land. That's why Apollo program did it successfully at that time. When Apollo program reached the Moon, it was the success ratio, I would say, was 6:1, which means that the safety estimation said that 6 astronauts, which is sent to the Moon, only 5 will return. That was the safety level at that point, and NASA said it's okay, we can go. Now it would be fully unacceptable. But still, it was succeeded, because landing to the Moon, extremely easy. No atmosphere, very, very low gravity. But landing on the Mars, impossible. Mars is one of the harshest environments. Why? Unfortunately, it has atmosphere. It has so little atmosphere that you cannot land without heat shield. But it has not enough atmosphere to use it for deceleration, which means you need to do everything, all the technology what we know, to land on the Mars. The second issue with Mars landing, how you know where you land. That's a big issue, because how a mission will build up. You have to send there all the supply prior to the mission. The supply will land at one certain point. How can you make sure that the astronaut vehicle landing close to the supply? What happens if it's far away landed? Astronauts have died. They cannot walk more than 10 kilometers in spacesuit. It's impossible. And this is just a very small example why we need to first go to the Moon, demonstrate technologies which can be reused in Mars environment, and then we can be sure that we are capable to do the Mars mission. Mars mission is much more difficult than we just see in the science fictions. No, it's not the reality. So, as I mentioned, Lunar Gateway, and after Lunar Gateway, in parallel, Artemis program foresees lunar bases, which means that in preparation of a Mars mission, we would like to start to increase our presence on the Mars. I don't know how familiar you are with the Apollo program, but the Apollo program was on the surface of the Mars only for a few hours. Later on, have maximum of 10 or 12 hours. But now, the mission of the Artemis program would like to go to the Mars, to the Moon, for 7 days, the first mission, and it would like to extend it to 30 days. And 30 days on the Moon surface requiring infrastructure, power plant, communication technologies, and so on, several things. Supplies, supply missions. It's a big, big program. And again, going back to the project management, because a very big program which has several parts of it in an international collaboration, and at the end, everything needs to meet at the same point on the Moon surface at the same time. There is no time to wait for a supply mission because someone was not able to fulfill its task in time. Then the astronauts died. And that's the point when we are almost ready to do the same then on ISS. When the governments are ready with the Moon missions, the technologies is in our hand to go to the Mars, then everything will be commercialized. Then why not? Because then the next step will be to using these technologies, go to the Mars. That's the strategical pathway now, which is established by the Artemis program. And as you see, hopefully by mid of 2030s, the first humans could land on Mars. Of course, it depends on several things. Artemis program is very difficult, and there could be delays, we always see it. But that's the reasonable first point in time when we can see humans on Mars. And then how a small country like Hungary can fit here? Because, of course, it's a big international program. And that's, I think, the most important keyword, international. No one can do it alone. This is an international collaboration, like ISS. Any crisis can happen on Earth. ISS cannot operate it alone. No one can do it alone. No one can do it alone to the moon and to the Mars. And that's why Hungary also could found its small pieces, because every country can found its experience. And space dosimetry is one of the national competence, as an example, where Hungary can contribute. And so on and so on. And that's why, first of all, we would like to found our national competencies to a national astronaut program. And it's then not just about to have an astronaut in flight. We would like to support our industry and research institutes that in the light of the strategy of the human spaceflight, the worldwide strategy, start to develop something which will fit there, which makes our market capable to compete against the international markets, the European, the US market. And then we can found our smallest piece in the future, how to contribute to the Artemis program, and what equipments, what technologies, what knowledge from Hungary could be transferred to a Mars mission. And that's the national strategy. And currently, we are participating in the Artemis program already, in parallel. So by starting this program, we identified these competencies. You will see soon a brief list. And then looking further, we would like to be part also in the Mars exploration program, the human program, which means that HUNOR, as we call it, which is in Hungarian a name as well. In English, it's called Hungarian to Orbit. It's an acronym. But this is not a one-shoot mission. It's like a program. What we would like to continue in collaboration with US, with the European Space Agency, and we would like to be part of this whole journey as much as we can. Then just a few slides about the program in details. So as I mentioned, the HUNOR program itself, it has 4 cornerstones. One cornerstone is science and research, of course. We would like to support national capabilities. Hungary has very long experience in space research. We would like to boost these capabilities, to support them, and to provide to them flight opportunity, technology, and science demonstration on ISS. The second one is technology and industry development. To support our industry, to provide technologies, especially reflecting to human spaceflight needs. Doesn't make sense whether it's a telecommunication technology, specific sensor technology, as a life support system. There are several small species which is required for a successful moon or Mars mission. The third one, to re-establish the human spaceflight competencies. And I'm really saying re-establish because Hungary once, a long time ago, had its capabilities. And now we would like to do it again. And the last one, of course, education and outreach. I think this is the program which really can show to the community and to the young people how interesting could be science and how interesting could be project management, product assurance management. Everyone hates it, I know, but product assurance is a cornerstone for any space missions. How many documents you should write, I think so. So these are the main cornerstones. The program is initiated by the government, and we are executing it with the Axiom Space, which is a US company, commercial entity, which will organize the travel for the first Hungarian astronaut flight in this program. And in parallel, we are closely collaborating with the European Space Agency, as Hungary is a member of the European Space Agency. European Space Agency and Hungary just now establishing an agreement. Within, we are offering astronaut time to ESA experiments, by ESA providing scientific and technological support for our R&D portfolio. So we have a very good agreement for the program with the agency. As I mentioned, Center for Energy Research, Space Research Department is executing the program. I am also working here. This is just a few slides to show you that this is really a very long experience, historical background, space research entity doing several human spaceflight and space research activities. So that's the core entity who is responsible for the program currently. And these slides try to summarize to you what is the main management principle behind of the program. Of course, such a program is very difficult to set up. You need specific rules. You need something behind which is governance, because it's involving R&D activities, it's involving a lot of governmental money. You need to convince people, you need to control how to do it. And what we have implemented is very similar how the European Space Agency as an agency is working. This is working such a way that as a starting point, first we define the so-called program declaration. In this program declaration, we're defining, based on the National Space Strategy, what is the objectives, what we would like to reach. It's then agreed by the government. Then you have a next document, which is called implementation rule. This document gives you a guideline how to manage the program at a very high level, like a user manual. This is also agreed by the government, but this is based on an international space standard, the ECSS, which is European Cooperation for Space Standardization. If you are interested, there is a big set within that for project management. That's the basis of our project management activities. And then, at last but not least, work plan. In the work plan, we are listing every activity, what we are doing, and periodically submitting to a so-called control board. Control board is formed by our ministry, the Ministry of Foreign Affairs and Trade, and they are approving everything. And when we are executing a program, we are going back to the program work plan. We are updating it and submitting to the next control board. And that's the way how we are working, and that's the way how the agency working in theory. If the agency activating a new program, as an example, they are always updating the work plan, asking approval of the member states, asking for money, and then executing. That's what we are doing also. The program itself divided into 4 sub-programs, because you can imagine it's a big program. I would not be able to manage everything, to oversee everything. There is 4 sub-managers responsible to the 4 cornerstones. There is an R&D sub-program identified. There is a selection and training, since we need to select and train astronauts. It's a very difficult task. We have a mission planning and operation. We need to plan the mission, and we would like to operate it from Hungary. That's also a big task. And at the end, we have partnership activities and education outreach. Partnership activity for such a program is always a big part, I would say. We need to have partners like NASA, ESA. We need to work with them, V4 countries, governments, etc., etc. That's a big task what we need to handle. You see here the main people, the faces behind, who are responsible for the given fields. Dr. Attila here is the R&D group lead. Gábor Magyari is the training and operations group lead. We have Dr. Claudia Vivian Nagy from the Semmelweis University, who is the medical lead. And then at the end, we have Balázs Zábori, delegated by the ministry, who is responsible for all the partnership activities and communications. Of course, below these people, several people within the team working for us. Here you see the timeline for the 3 main sub-programs. Of course, the partnership activities is not listed. You can see that this is just a summary, but at the end, all these programs, sub-programs, need to meet at the same point within a mission, what we call HUNOR 1 mission. The HUNOR 1 mission is currently foreseen end of 2024, early 2025, depends, currently a little bit. ISS schedule is daily basis changing, but let's assume early 2025. Currently, for the selection and training sub-program, we announced a national astronaut selection last year. It was finished or closed January this year, and we are just now finishing the last phase of the selection. We will announce the results within 2 or 3 weeks, I hope so, and then we will start the training. The training for our mission, which will be a 30 days R&D mission, is 1.5 years. That's the minimum which is required to go through all the mandatory trainings which need to be presented to NASA to get the flight authorization for our astronauts on board the SpaceX vehicle, and making it possible that our astronaut can live and work on ISS. In parallel, we need to execute our R&D program. We need to do the science and technological developments making sure that these equipments and developments are ready earlier than our astronauts, because we need to send it prior to the astronaut flight to the ISS. We would like to give to our astronaut these equipments to execute the experiments for our national R&D entities and industrial entities. And this is the key point. One of the most valuable things on Earth currently is astronaut time. You cannot buy it. You cannot say to anyone else, there is no shops for that you would like to do something on ISS and I'm buying 20 minutes from an astronaut. And that's what we would like to offer in theory to our industry. Because in space industry, one of the key issue always that if you have a development, even if you execute it, entities always asking, are you capable to demonstrate it? Is that flight proven? Then you will say no. But if you can demonstrate something on ISS, then everyone would say, okay, it's working on ISS, you demonstrate it, I will buy it. And that's the big step, which is very difficult to achieve, but we offer it. But it means that we need to meet at a correct point. And at last but not least, we need to provide a mission planning. And our plan that we build up a mission operations center in Hungary in collaboration with the European Space Agency. The center should be ready by mid of 2024 latest. We need to demonstrate its capabilities, and it means that we can directly connect from here, from Hungary, to the ISS, and we will operate everything related to our astronaut from Hungary. Not from NASA centers. No, we can do it from Hungary. And later on, we would like to offer this capability to the agencies, to the Artemis program. We would be capable to operate R&D experiments on the moon, on Gateway from Hungary. That's the end goal by this subprogram. Just as I mentioned, a list of our identified national competencies. We have a lot, but these are the main ones, I would say. These are the main R&D competencies of Hungary. This is in line with our national space research strategy in theory. I will not go through the list, I'm just highlighting a few things that there are several key things in this list which is required for the human spaceflight. Just an example, material sciences. We need new type of materials that we can use in space. We need technologies, how to build structures in space. It would be much easier if we go to the moon, be using the materials available on the moon's surface and build from that something, a house, everything there. And we not bring it from here to there. Why we want to bring everything from the Earth to the moon if we can do it there? The second very interesting example, space nutrition. I think not many of the people are aware of the fact that we can print food. 3D printing capable to print food. And that's a very challenging thing, how we can manage to live long term in space. We can send there just very low amount of materials. You can store it in a vehicle, on gateway, etc. And later on, you can print food, and it will look like if you would eat here in a restaurant while you are on the moon's surface. These are just small, very interesting things, I think, which shows you that how wide the scale of the technology solutions required to live on a moon surface or on a Mars surface. And also telecommunication. Telecommunication is a key aspect. As I mentioned, how can you be aware that you are landing on a correct position in Mars? You can do it just if you have a telecommunication satellite system around with which you can communicate. That's how we are landing on Earth. When you are landing to Earth and the heat shield is working, then you cannot communicate with the ground. The heat shield not allows you, it's an electromagnetic shield. No communication can go down. Every vehicle during the landing process communicating with satellites, and that's how they are positioning and knowing where it will land. And we should do the same. We need to build small satellite constellation first around Mars, and we need to do the same for the moon. Which means that even we can land on the other side of the moon if you have a satellite in orbit, which helps you to communicate with the Earth. These are small things, but this should be there when the astronauts arrive. Without that, the life is much more difficult. Regarding the R&D development, we released an open call that was divided into 3 different types of activities. This is listed here. First, we wanted to ask for scientific outreach activities, any kind of core, high school activities, anything which can be done from the ISS using our astronaut time. Usually it's always part of any space flight. The third one is scientific and technological experiments, making use of the technologies available on ISS. ISS is a laboratory. On ISS you have several things that you can use for an R&D mission, a research which was not done before. So we asked our community to propose something. And at last but not least, complex developments, any type of development, for technologies which is not existing, but would be interested for the human space flight. And I think this is something which is usually interesting to everyone, how a selection of an astronaut is ongoing. It's divided into 3 phases. When we started the selection process, we received 244 applications from Hungary. It looks not much, but for a country like this, it's much. It's very interesting because in parallel of our selection, ESA doing its own selection. It was an interesting fortune, I don't know. ESA doing astronaut selection every 10 years or 20 years, so it's not common. And we did it parallel, and we supported each other. We changed experiences, and it was very interesting. From that first phase, we've just made some administrative selection, which means we checked that the applicants are in line with our administrative requirements regarding its education, regarding its language knowledge, etc., etc. We ranked them. Then 100% was moved further to an aeromedical selection state. The 100% immediately go down to 60 after a very easy pre-screening. Most of the personnel are not fitting the aeromedical requirements, to be honest. And at the end, we had 45 personnel who went through a much more detailed aeromedical test campaign. And here, the most critical thing, the psychological test campaigns. Most of the people is not capable to meet the requirements psychologically. Because you should have a very strict personality to make sure for the agency that when you are living in a closed volume with people for months or for a year, and you are absolutely would like to go home, you don't care anymore anything, and you got an order, you execute it immediately without questions. It's not an easy thing. And at the end, we had only 8%. 8% from 245 or 44 who was capable to meet all the aeromedical requirements and went to the third phase. And we are just now finishing the third phase. The third phase is much more focusing on technical skills. So we are providing courses, we are defining experiments. The astronauts, candidates should do experiments, execute experiments which are impossible to be executed, and we are examining what is happening if you get a task which cannot be done, how you react, what you try to do, because it will happen on ISS, for sure. And these things, and now we are at the end of this phase, and we will select 2 persons, only 2, the 2 best candidates, and one will be the primary and one as a backup, and these 2 persons will go into the last phase, the training phase. That's the status for the selection and training. And this slide is just about the whole training process, how an astronaut training looked like. This is also phased a little bit, and our idea to do as much as we can in Hungary, here. We would like to establish the capabilities to train astronauts. So the first 2 parts is very easy to do in theory. The first one is an orientation training, which is more or less theoretical courses to learn a little bit about aerospace engineering, system space safety problems, space environment physics, blah, blah, etc., such a things. The basic training is already started to focus on human spaceflight disciplines, to to start to learn about what will happen during your flight, what you will feel, what environmental factors will affect you, what could happen, how a vehicle is working, what is happening when you are feeling a vibration, why it is happening, and what is dangerous, what to do if scenarios. This part is already done together with the European Space Agency, because here we have already very specific basic training courses for which we do not have national experts, of course, but the ESA has. Then the third one is the mission-specific training, which is covering the learning courses for the astronaut, how to handle our equipment. So mainly our equipment developer go to the astronauts and teach them what to do on ISS. And then starting the last two part, which is the most excited, I would say, the fourth phase is done by Axiom Space in the US, which is the vehicle-specific training, where the astronaut will exactly learn what and why happening in the SpaceX vehicle, and what they can do and cannot do, what's the rules there, etc. And the very last training is done by NASA and ESA together, which is the ISS training, where you will learn the same for the vehicle, but for the ISS. To learn what and why happening on ISS, it's not trivial. Using the toilet on ISS is not trivial, to be honest. It's a tricky thing, and such a thing, eaten on ISS, it's not trivial, very much not trivial. How to drink on ISS, there are rules, very strict rules. So you have to learn a lot and prepare yourself before you can go there, and you need to pass every time exams, and exams are suddenly repeated, unexpectedly. And that's the reason why this is a very difficult process, because at a certain point, suddenly there is an exam, and they need to pass it. They cannot fail, because then they lose the flight ticket immediately. So that's why we need a backup, because what if happening that 1 month prior to flight, we lose our astronaut flight ticket, we need a backup. This is just one slide, but I mentioned that the HUNOR 1 mission will make use of the SpaceX vehicle. This is the Dragon vehicle, which is currently commonly used to deliver people on ISS. Usually 4 people is sitting there. So that's the main visiting vehicle currently. And at last but not least, I would like to show you at the end some achievements and highlights, which is, I would say, already an outcome of the program. Technology. One good example, a product, a space industrial product, which is, I think, relatively famous from the Hungarian Space Agency, which is a space dosimetry monitor system called PILLE. This is a system which was developed originally for the first Hungarian Astronaut 5 in 1980. That was the first time when it was flown in space. That was the version 1. And now we have version 5 on ISS. And in the meantime, it is continuously used in space. This is the longest space hardware ever been used in space. Almost 40 years ago, it is continuously present in the space. Different versions, but it's there and still used. And our astronaut will use the 6th version in the space. That's clearly demonstrating what a small country, if investing, can reach. We are contributing just a small piece, but everyone would like to have this. NASA using it, ESA using it, Russia using it already, or used in the past. That's a big success and an example what we would like to achieve with this program. The second highlight is our Artemis program contribution. Based on these national competencies, we was able to win a big contract, a national lead contract. A Hungarian consortia was able to win against very big players, and now Hungary is providing the first scientific payload for the Gateway program, which will be operated inside the Lunar Gateway. This is also focusing on dosimetry, cosmic ray measurements, etc. But this is the very first time that a small country like Hungary can send something into the moon orbit and operate there. And it was a big, big contract against big competitors, like Thales, as an example. And the third highlight that Hungary also won a big contract in related to the Mars robotic exploration. There is a big mission called Arrow, which stands for Earth Return Orbiter. This is a very complex mission, which is part of the so-called Mars Sample Return mission, in which NASA and ESA together would like to bring back a few hundred grams of Mars soil to the Earth to allow our scientists in our labs to check what's inside. This is very, very complex, but the very last mission for that is a big satellite, like a bus, called Arrow, which is going to travel from Earth to Mars and then back to the Earth. That's the first time in humanity that we are building something which is capable to travel from here to the Mars, orbit the Mars, catch a sample bag in orbit, deorbit the Mars, and go back to the Earth and land. And for that mission, Hungary was won again a big contract where we are just studying the same, the whole cosmic radiation environment during the whole trip in preparation of future human spaceflight to the Mars. And regarding the program itself, as I mentioned, the astronaut selection is almost done. I think that's a very big achievement. It was a big task for all of us within the program that we was able to set up, based on international standards, a selection procedures for each of the phases. We carried out the selection, and now we are almost ready to announce the next candidates of our national astronaut program. For the R&D development, we have just finished the open call. We closed it, we evaluated it, and in parallel, we finished a so-called definition studies of big equipment development, which was proposed by our industry, which is now will be subjected for submission to the HUNOR control board. And based on the approval of this control board, we will initiate these development contracts very, very soon. So we will be in line, which means that our industry and R&D entities will have 1.5 years in parallel with the training to prepare themselves for the mission itself. For the mission planning, we are currently in a discussion with the European Space Agency, and hopefully the construction work for the mission planning center, which will be in Hungary, could start within a few months. So we are in the planning period already. And for the partnership activities, I think we are already in very good connection with most of the agencies. We are ready to sign an agreement with the European Space Agency. And we are in connection with the V4 countries, which is from the governmental perspective very important. And we are also in very good collaboration with Axiom Space, SpaceX, so with the companies in the US market who is responsible for the whole space flight itself. Yeah, so that was my summary. I think there is now time for questions. Thank you for your attention.
Balázs, thank you very much. I told you that it will be interesting. But before we ask questions, I have to remind you, I have to ask you to fill in the customer survey. The gifts are already on the table, and if you do not fill it, I have to drink all the bottles of wine on the table. Balázs, thank you very much, and special thanks for discussing project management in your presentation as well, because it was the question I wanted to ask first, that before you send the spaceship to the moon, do you open the PMI book and work by it, or
no,
do you have professional? It's a serious question. So, do you have professional project managers in the program? It
yes.
looks to be a huge program with many members. So, do you hire somebody who's an expert of project, not spaceships or any kind of technology, but project management?
That's an special problem for us because we need personnel who is aware of the European Space Project Management Standard, the ECSS. We are working based on that. But there is no learning courses within Hungary and not much within Europe. So we are hiring project manager people mainly from the automotive industry, and we are teaching them through the program how to work against the ECSS. That's a serious problem.
So it's a very important component. It's a prerequisite for international cooperation.
Exactly.
That you have to work by the same rules and you have to speak the same language.
Exactly. It's everyone who is going into this business after a few days saying to me that this is a business of acronyms. Everyone is talking about acronyms, and if you would join a meeting where we are just talking about project management things, you would see acronym, and not VBS. Acronyms which is unknown for most of the project manager coming from different disciplines, and then it takes a long time to learn.
So project management is the English language or the Esperanto of this research program. Yes?
And
language everybody has to speak.
And it's fully different. That's my experience from the people coming from automotive industry or different type of industry. They are saying it's similar like the military, but still different, and focusing on different areas, and mainly focusing on configuration management, and based on a very complex documentation management rules set. So you need to document everything what you are doing, because if something happening on ISS or any error happening, you need to have every document available to reconstruct what could be the reason to that. Very good example, the Apollo 13. If you remember, there was a big documentation film, there was a big error on the Apollo 13. And why the engineers was capable to recover them, to bring back to them, because they had every document there, how the ship was built, what happened there, who inspected, where and what type of screw is there, whether glue is used or not, everything. And based on that, you need to have a perfect knowledge on what you have in space.
Are these films realistic? Because I think that Matt Damon managed to get to the Mars and yes, produce potatoes, maybe. So is it close to reality, or these films are results of fantasy?
It's a little bit far away from reality. For the Mars, the big problem is again the radiation, and we are not thinking about the fact that still on ISS it's not so dangerous, because ISS is within the magnetosphere, still within the magnetosphere. The radiation level on ISS, hundreds times higher than here. If you go to the moon, 1,000 times. If you go to the Mars, 10,000 times. It means that if you live on the Mars surface for a few months, you will be almost died when you arrive back to the Earth. And no one can protect you. So it's a science fiction that we have a big camp on the surface of the Mars. When we go to the Mars, we need to live under the ground. No other way. For the moon, it's not makes sense, because for the moon we can be there only for 30 days. The reason for that, because the moon night is one of the most challenging things. When the night is coming, which is every 30 day on the moon, then the temperature is going down minus 200 or something like that. After that, you do not have solar power. You cannot heat up anything. You cannot launch anymore anything. No thruster can operate at that temperature. So a night survivor on the moon is currently impossible.
There is an interesting question about the candidates, the astronaut candidates, that you showed us a photograph of the candidates. Is it a boys only program, or
Sorry,
is it a boys only program, or
no.
ladies are also applicants? No,
we also hope
I saw maybe two or three ladies on the photo.
Of course, there was lady applicants, but the rules was the same. But of course, the lady applicants, the percentage of them was much less. So the chance at the end also much less. But we see the same at the ESA level. They had a much bigger set of applicants, and around 20 or 15% was only women. And at the end,
ladies were in space, I think.
Yeah, they can do it.
Tereshkova was the first.
Yeah, but it's much more easier. They had 10,000 applicants. It's a much bigger personnel from where you can start. We had only a little bit more than 200. And if you have there a 10% of women, then the problem is still there.
Are you one of the applicants? Do you want to fly?
No. I personally know several astronauts. And the main thing here to be noted that most of the astronauts will never fly. You need to realize that if you see the ESA astronaut campaign, they are selecting 10 or 15, and 1 or 2 will fly ever. And then for the others, they are living the same strict life, the same limited life. everything the same, and at the end, nothing is happening. The dream is no more a dream.
Bálint Magyar was the astronaut, Hungarian.
Yeah, the
Who
same.
did not fly.
Did not fly,
It was a
exactly.
Emotional problem,
Exactly.
as
So
far as I know.
you have a life where you are restricted to almost everything. You cannot do anything, just those things which is approved by your boss. And this is valid for everything in your life. And at the end, they are saying, thank you, you are too old, go home. That's all. And that's happening.
And become a project manager, maybe, yes. Well-paid job. Can you tell us something about the risk management system of the program? Because I suppose that you face many risks. So
Yeah, for the risk management, there is a dedicated standard within the ECSS. It's very well describing how a risk register should look like. And usually it's a very complex table where every risk item should be listed and connected to a critical item list. So we have two lists, critical item list and risk item list, and this is interlinked to each other. And critical item and or risk item could be almost everything. It can be a function, it can be a mechanism, it can be a people, it can be a problem, it can be everything. It's based on our judgment, the project management, the risk manager judgment, and there is a dedicated manager to that. It cannot be the project manager. We should nominate an aerospace engineer who is the risk manager. It's always an aerospace engineer because the main risks always related to such a program is not the cost. The agency will pay for everything, I know. But the risk is always related to the technical problems. And it's always better to list it and to show, hey, the thruster will not work. What to do to avoid it? So here the risk management is one of the key aspects of project management.
from the point of view of risk management, wouldn't it be better to send a robot instead of a human being? A robot with artificial intelligence to Mars? So why do we stick to human beings? Are they better?
Yes. The problem the same, that still our biology can withstand the radiation better than the technology that we have.
Really?
Yes. The electronics, which is inside to everyone's pockets, I would say, if you send it to the space and radiate in the space, will no more work. The memory will be corrupted. The software will be over. You can write very good MIs. You can send it to the space, and there is a big chance that within a few months it will be non-operational because the software memory is corrupted immediately due to a radiation particle. And then what to do? Then you have just
It's a surprise for me. I did not know.
a non-working material on space.
Okay. Thank you very much. We are running out of time. So we were very pleased to be with you and ask the first astronaut to send us the postcard when he will be on the moon or on the Mars, and we will put it on the screen. So thank you.
Thank you for the
really
invitation.
very
Thank you very much.
interesting.